So in this question, we have a data table. And the first thing we might notice, we have time and position, but they seem to be reversed in order of what they should be. The next thing we might notice is that the delta t's are equal. And we look at the delta x's. Well, that's 0.1, and this is 0.3, and this is 0.5, and this is 0.7. So we can see that the delta x is increasing at a constant rate as well. So clearly, if the average velocity is delta x over delta t, and the delta t's are equal, and the delta x is increasing, the average velocity is increasing. And if the average velocity is increasing, the thing is accelerating. Now, we may have intuited that from the beginning, looking at that like so. So now we're told there's a 2 kilogram mass starting from rest, so V0 is 0. It's pushed with a constant force, and of course, constant force is the rate of change of momentum, and the change in momentum is m delta v over delta t. So in this case, the mass would stay constant, and so if the force is constant, the rate of change of momentum is constant, the mass is constant, the delta v over delta t is constant. So that means the acceleration is constant. Position is shown. What is the magnitude of the change in momentum? Well, we have a change in momentum, which is m delta v. Now, the m we know is 2, but we don't know delta v. Delta v is v minus v0, and v0 is 0, so we know it's twice the final velocity, but we don't know the final velocity. We can find the average velocity, which is delta x over delta t, and delta x is 1.6, delta t is 4.0, which gives us an average velocity of 0.4 meters per second. That's our average velocity. Well, since the acceleration is constant, we can use our other average velocity formula, which is v plus v0 over 2. And of course, v0 is 0, so that means that v bar is the final velocity over 2. So the instantaneous velocity at the end is twice the average velocity. And we know the average velocity is 0.4, so the final velocity is 0.8. So we have 2 times 0.8, which is 1.6 kilogram meters per second. And that is our choice number 3.